everyone, Ken here, and welcome to the Metropolis. On today's video, we are going to be discussing robotics, and not just robotics, but some exciting developments in the field of self-replicating robotics. That is, robots that can build not just other things, but actually larger robots themselves. So, although this is a nascent and still evolving field, it's still in its very preliminary stages. There is development, so let's have a look at this article from MIT. Flocks of assembler robots show potential for making larger structures. Researchers make progress towards groups of robots that could build almost anything, including buildings, vehicles, and even bigger robots. Pretty awesome. And by the way, I'll leave this link to this article in the description below, just like we do for every article that we include in this channel. So here we have some photos of the current iteration of the assembler bots. They really, to me, kind of look like Kinects. That's kind of what I think of when I see them. And these are obviously not nowhere near the final product or iteration, but as we'll see in a quick video that they have here, let me mute this. All right, and just to kind of see them in action. Let me slow it down. I've got it, I think, at double speed here. Go to normal speed. All right. And so you can see every one of these units, or they're known as voxels, a term from computer graphics hardware, computer graphics design software, and whatnot, video game software, three-dimensional graphics design is where that term derives. Voxels instead of pixels. Pixels will be the thing on a 2D plane. Voxels are for 3D space. So logically, they have named these little units voxels. And this is the preliminary thing that will eventually lead to the ability to practically, have from the ground up construction of larger items such as buildings, houses, furniture, whatever, what have you. So let's take a look at the article. Researchers at MIT have made significant steps towards creating robots that could practically and economically assemble nearly anything, including things much larger than themselves, from vehicles to buildings to larger robots. The new work from MIT's Center for Bits and Atoms, awesome name, builds on years of research, including recent studies demonstrating that objects such as deformable airplane wing and a functional racing car could be assembled from tiny, identical, lightweight pieces, and that robotic devices could be built to carry out some of this assembly work. Now, the team has shown that both the assembler bots and the components of the structure being built can all be made of the same subunits, and the robots can move independent in large numbers to accomplish large-scale assemblies quickly. So I wonder if that actually means that there's two sides to it. These might be the assemblers, which are based on smaller component parts, and they can be built from the same parts. Like I'm not sure if the voxels themselves. I know the voxels are these actual large structures, but I don't know if the idea is to shrink these down and then also have them transfer smaller units that then build more voxels, or if the voxel is the unit. But from reading this, it seems like it's a two-part thing with the voxel and the subunits that the voxel is made of. Could be wrong there. Let's read through it a bit more. The new work is reported in the journal Nature Communications Engineering in a paper by CBA doctoral student Amira Abdel Rahman, professor and CBA director Neil Gershenfeld, and 3 others. A fully autonomous self-replicating robot assembly system capable of both assembling large structures, including larger robots, and planning the best construction sequence is still years away, Gershenfeld says, but the new work makes important strides towards the goal, including working out the complex tasks of when to build more robots and how to make them, as well as how to organize swarms of robots of different sizes to build a structure efficiently without crashing into each other. So obviously this will have a lot of AI involved, and it's hard to see from just stills of the video, but there's actually, they're robots, so there's computer material, there's computer wiring within these stems, essentially connecting this whole unit. So it's not just these isolated bits of plastic. I believe that there's communication going on throughout all these units, which would make sense because they need to be able to configure in any sort of way, any sort of configuration with these robotic Kinects. So, as in previous experiments, the new system involves large, usable structures built from an array of tiny, identical subunits called voxels, the volumetric equivalent of a 2D pixel. But while earlier voxels were purely mechanical structures, the team has now developed complex voxels that each can carry both power and data from one unit to the next. It's interesting that they can carry power as well. This could enable the building of structures that can not only bear loads but can also carry out work, such as lifting, moving, and manipulating materials, including the voxels themselves. When we're building these structures, you have to build in intelligence, Gershenfeld says. While earlier versions of assembler bots were connected by bundles of wires to power their source and controls, what emerged was the idea of structural electronics, of making voxels that transmit power and data as well as force. Looking at the new system in operation, he points out there's no wires, there's just the structure. So I guess that makes... I'm assuming that they have removed the wires and then they might be transporting batteries or some sort of energy source, stored charge, whatnot. So they seem to be scaffolding the milestones and actually creating functional, practical, self-replicating robots. The robots themselves consist of a string of several voxels joined end to end. These can grab another voxel using attachment points on one end and then move inchworm-like to the desired position. So the robots themselves consist of a string of several voxels joined end to end. Right, so I do believe that these are the whole voxels, because you can consider this guy, probably here, who's walking around. This is a robot, quote-unquote, even though it's made up of these smaller voxels, I believe is the idea. Gershenfeld explains that while early systems demonstrated by members of his group could in principle build arbitrarily large structures, as the size of those structures reached a certain point in relation to the size of the assembler bot, the process would become increasingly efficient because of the ever longer paths each bot would have to travel to bring each pieces to its destination. That makes sense. So they're basically refining the mechanistic logistics of how this would work, and not limiting themselves to one point on the unit where building can happen. Article goes on to say, while there has been increasing interest in 3D printed houses, today those require printing machinery as large or larger than the house being built. Again, the potential for such structures to instead be assembled by swarms of tiny robots could provide benefits. And DARPA is also interested in work for the possibility of building structures for coastal protection against erosion and sea level rise. I'm sure that's the only reason. Aaron Becker, an associate professor of electrical and computer engineering at the University of Houston, who was not associated with this research, calls this paper a home run and an innovative hardware system, a new way to think about scaling a swarm and rigorous algorithms. Building self-replicating systems is a classic challenge, not just in science, but even in science fiction literature. Something that only nature has really achieved so far, so this is extremely exciting work, says Sander Fakete, a professor of algorithmics in the Department of Computer Science at Technical University Braunschweig, Germany, who was not associated with this work, although he has worked with CBA in the past. So they're getting a lot of buzz for it. And I would say this is exactly why why I would examine something of this nature, why this sort of thing excites me, because it is it is a precursor to a lot of science fiction scenarios, whether they be good or bad or a mix of both. Creating a mechanical analog for the biological system of self-replication could have a lot of uses and could have a lot of downfalls. But to achieve the kind of world-traveling goals and solve some problems, it's definitely something that I think we should have in our toolbox, whatever it may be, and something that I'm excited to see the future of. Just obviously it would have to be, monitored like any new technology and made sure that it is used with best intent. But something like this, I feel like with the correct practical application in the future would be as ubiquitous as power outlets in your house, essentially. It seems there would be infinite applications, and as long as the actual voxels themselves and the system that they're based in is fairly innocuous and is not something that, has a lot of vulnerabilities or something that can be hacked. Someone can't use your voxels in your house to create like a machete that stabs you or something. I don't know, poor example. But as long as that's not the case, there's endless applications for this. So I'm excited to hear about this nascent but developing technology. But what do you think? Is this dystopian for you? Is this utopian for you? Indifferent, somewhere in between? Let me know what you think in the comments below. And if you like this content, if you want to see more of it, please feel free to hit that like button and subscribe for more. I'll be posting new videos every day. Have a great day. Until next time, bye.